The fourth method for wastewater treatment is determination of oil and grease. Aim: to determine the quantity of oil and grease present in given sample of water by partition gravimetric method. Principle: the oil and grease contents of domestic and certain industrial waste and the sludge is of an important consideration in handling and treatment of these materials for ultimate disposal. Knowledge of quality of oil and grease present is helpful in proper design and operation of wastewater treatment system. The term grease applies to wide variety of organic substance that is extracted from aqueous solution or suspension by hexane. Hydrocarbons, esters, oils, fats, waxes, and high molecular weight fatty acids and are major material dissolved by hexane. All these materials have greasy feel and are associated with problems in wastewater treatment related to grease. Three methods by which oil and grease are estimated are the partition gravimetric method, partition infrared method, and solvent extraction method. Though method of partition gravimetric method does not provide needed precision, it is widely used for routine analysis of sample with high oil and grease contents because of simplicity of special instrumentation. In second method, partition infrared method, adequate instrumentation allows for measurements of as little as 0.2 milligram oil and grease. And third method, the solvent extraction method, is identical to gravimetric method, but it is designed for samples that might contain volatile hydrocarbons that otherwise would be lost in solvent removal operation of gravimetric method. In partition gravimetric method, dissolved or emulsified oil and grease is extracted from water by intimate contact with trichlorotrifluoroethane, petroleum ether or hexane. Apparatus include in this practicals are beakers, separating funnel, distilling water, desiccators, and vacuum pump. And this is analytical apparatus. Reagents are hydrochloric acid, and trichlorotrifluoroethane. Procedure: collect about 1 liter of sample and mark sample level in bottle for later determination of sample volume and acidity to pH 2 or lower, generally 5 milliliter hydrochloric acid is sufficient, and transfer to a separating funnel. Carefully rinse sample bottle with 30 milliliter trichlorotrifluoroethane and solvent washing to separating funnel. Preferably shake vigorously for 2 minutes. However, if it is suspected for stable emulsion, shakes gently 5 to 10 minutes. Let layers separate out. Drain solvent layer to funnel containing solvent. Moisten filter paper into a clean, evacuated distilled flask. If a clear solvent layer cannot be obtained, add 1 gram sodium sulfate if necessary. Extract twice more than 30 milliliter solvent each time, but first rinse sample container with solvent. Combine extracts in evacuated distilling flask and mesh filter paper with an additional 10 milliliter to 20 milliliter solvent. Distill solvent from distilling flask in water bath at 70 degrees Celsius and place flask on water bath at 70 degrees Celsius for 15 minutes and draw air through it with an applied vacuum for final 1 minute after the solvent has evaporated. If residue contains visible water, add 2 milliliter acetone evaporates on a water bath and repeat the addition and evaporation until all visible water has been removed. Cool in desiccators for 30 minutes and wait. Observations are temperature of measurement, which is 70 degrees Celsius, mass of evacuated flask is 30 gram, mass of evacuated flask plus residue is 30 plus 0.001 is equal to 30.001 gram, and mass of residue is 10 milligram, and volume of sample is 40 milliliter, and these are supposed values. And by calculating the oil and grease, the final answer is 0.0025 milligram per liter, where A is mass of evacuated flask and residue, and B is mass of evacuated flask, and the result is the amount of oil and grease in given sample is 0.0025 milligram per liter. And these are the references which I have used, and thank you so much. That's all from us.